These pointers can be turned like the hands of a clock, and the user measures the angle of the stars and planets in relation to the horizon to calculate his location. He caps the bushing with a screw on one side and a nut on the other. He secures the assembly with a specific amount of torque to allow the dial and pointers to move freely. He then slips a metal ring through the top hole of the astrolabe so this instrument can be linked to a chain if the owner wishes. He spins the dial and pointers to confirm that they don't snag on the outer lip of the instrument. Centuries after its heyday, this incredible instrument still fascinates. The amount of information that can be gleaned from holding it to the sky is astounding. More than latitude, the astrolabe can be used to tell time, determine seasons, and predict the future with horoscopes. Of course, it takes a basic understanding of geometry and astronomy to use it. To the trained eye, this astrolabe now reads 1 p.m., proving that this instrument from another era can still provide up-to-the-moment information.
So why don't we learn today how to use the astrolabe? If we had to evacuate from a current location where each and every one of us lives, then where would we go? Do we even know that? If suddenly there was no communication system, no internet, no phones, then what? What would we do? We would be probably completely lost like Tom Hanks in that movie Castaway. We rely on GPS, on internet, smartphones and tablets, and we have no idea how to find ourselves in a given location just by looking at the stars. And we easily could, as we were able to see that just a second ago. But whoever is in control of our education system doesn't want us to know. So let me remind you what the astrolabe can do, since it has to do with our flat Earth situation and my explanation of the southern stars and the Milky Way. And please pay attention to what exactly is in the center of the astrolabe.
On a scientific instrument called the astrolabe. Using this instrument, they could measure the angular distances between celestial objects to calculate latitude. It was the medieval equivalent of the GPS.
And it was a device that, in fact, is a model of the sky. So the different parts of the astrolabe in this particular type, the rete corresponds to the position of the stars, the plate corresponds to a coordinate system, and the mater has some scales and puts it all together. And basically the concept is, how do you represent the three-dimensional image of the night sky that surrounds us onto a flat, portable two-dimensional surface? The idea is actually relatively simple. Imagine that the Earth is at the center of the universe, and surrounding it is the sky projected onto a sphere. Each point on the surface of the sphere is mapped through the bottom pole onto a flat surface where it's then recorded. So the North Star corresponds to the center of the device. The ecliptic, which is the path of the sun, moon, and planets, correspond to an offset circle. The bright stars correspond to little daggers on the rete, and the altitude corresponds to the plate system. Now, the real genius of the astrolabe is not just the projection. The real genius is that it brings together two coordinate systems so they fit perfectly. There's the position of the sun, moon, and planets on the movable rete, and then there's their location on the sky as seen from a certain latitude on the back plate. Is by a picture of the sky. He would know where things would fit in the sky. He would not only know what time it was, he would also know where the sun would rise and how it would move across the sky. He would know what time the sun would rise and what time it would set, and he would know that for essentially every celestial object in the heavens. In fact, there's a text that has over 1,000 uses of this first computer. On the back, there's scales and measurements for terrestrial navigation. You can survey with it. The city of Baghdad was surveyed with it. It could be used for calculating mathematical equations of all different types, and it would take a full university course to illustrate it.
This is very interesting that the astrolabe resembles flat Earth model. Everything is in the right place. The North Pole is in the center. The Sun moves between Tropic of Cancer, Equator, and the Tropic of Capricorn. Even the time is correct how we calculate it on the flat Earth map. So 2,000 years ago, people were looking at the stars and they knew precisely where everything was. And we look today, and most of us don't know anything, nothing. This is the reality of the 21st century, where most people know only whatever they've seen on TV. But 500 years ago, people not only knew the Earth was flat, but were able to build instruments such as astrolabe, made out of brass or other similar material like that. No fancy electronic gadgets, no wires, no electricity, no batteries needed, only common sense, some mathematics, and basic flat Earth knowledge in order to tell and predict time, date, location, phases of the moon, lunar and solar eclipses, and so on. 500 years ago, the astronomical clock such as the one in Prague that was built in 1410 were nothing unusual. All major cities had them and they all looked very similar, with the circle of zodiac signs rotating around central point, the North Pole or the Polaris star. And of course they had the sun and the moon rotating around it.